antiderivative. For example, if I am given the velocity, which I know is the first derivative of the distance function, so given the velocity, given v of t, find s of t. We haven't encountered this before. We were given the function, we were asked to find the derivative. Now we're going backwards. We are given the derivative. Somehow the velocity function was determined. We would like to determine the distance function. So that's what the concept of anti-differentiation. Undo the derivative, in other words. So go back from the velocity to the distance. Okay, so this is the distance function. So a very important concept or idea here is the notation. So if we are given a function, then we will determine the uppercase f of x. This will be the antiderivative. If we are given f prime, then we will find f of x. And you can say, what's the big deal? You will see what's the big deal when we get to another section in chapter 5, a particular section in chapter 5. So if I'm given a function, for example, f of x equals 2, find the antiderivative. And I'm going to say the most general antiderivative. I'm going to use uppercase f of x, and I'm going to write which function prime is 2. What do I differentiate to get 2?
2x.
That's it. Plus a constant c. So this is basically a family of functions that have that derivative. All of them. If you want c to be 5 or negative 10 or negative 1500 or positive 1,000,000. All these functions will have the same derivative. So it's a family of functions with the same derivative. Now, if I'm given f prime of x equals 2, the notation will be f of x equals 2x plus c. And again, you can say, what's the big deal? You will see in chapter 5. So depending on the form or the function, the way it is denoted, this function was denoted by f of x. I'm asked to find the most general antiderivative. I will use uppercase f of x. If I'm given specifically f prime, which is still, this is also an f prime for this, right? But if I'm given the notation f prime equals 2, I have to use f of x equals 2x plus c. And this will come into play a little bit later. Okay, so few things before we look at examples. I am given a function f prime of x equals e to the x. Can anyone give us the antiderivative? Not the most general, just the antiderivative of this. Or if you want the most general, why not? What do I write? What function prime or family of functions? Yes, indeed, e to the x plus a constant c. Perfect. What if I have f prime of x equals 1 over 1 plus x squared? Can anyone give us the antiderivative, which function prime or family of functions prime will be this.
So arctangent.
Very good. Very good. Awesome. Great job. Okay, another one. F prime of x equals 1 over x. Which function prime has this function?
Is it ln x plus c?
Very good. We have to use the absolute value, and let me explain why. So this is very important to understand. Why? Because we can never omit the absolute value unless we are told x is greater than 0. If I'm told that x is greater than 0, of course I will omit the absolute value. Makes no sense to put the absolute value on a positive number. But let me explain why. So let's look at natural log of the absolute value of x. I have to start with the absolute value. We've done this in chapter 2. Can anyone refresh our memory? What are the options for the absolute value of x?
If x is 0 or greater, x equals x, but if x is less than 0, x absolute value? No, x.
You're right. If x is less than 0, the absolute value has to be replaced by negative x. Good. Now, when I plug this in the absolute value, I cannot plug in the equal symbol, though. So now, natural log of the absolute value has two possibilities. And the possibilities are natural log of x for x strictly greater than 0. This is not defined at 0. Or natural log of negative x, according to this, when x is less than 0. So now let's differentiate. Okay, so I want to differentiate this function. Well, let's see what we get. Natural log x prime is, we know, is 1 over x. Of course, for x greater than 0. What about this one? This is natural log of a function. It's not plain x, it's negative x. What is the derivative of this? How do we start?
Negative 1 over x?
Negative 1 over x times the inner function prime, which is?
Negative 1.
Negative 1. So that's why I get the same thing. They are the same. Therefore, whenever we are looking at f prime being 1 over x, the antiderivative is natural log of the absolute value of x. Why? Because even x is, if f of x is positive, I get this. If x is negative, I get the same thing. Good. Now let's think in terms of the power rule. Let's take it slowly with an example. Let's suppose I want to differentiate x cubed. What do I get? This is not the antiderivative. I'm just asking what is the derivative of x cubed?
3x squared.
3x squared. And now let's think for a moment. I would like to get a function whose derivative is x cubed. What function prime will be x cubed? And here's how we do it, and this is the power rule. We increase the power by 1, and we divide by that number. How come? Yeah. Of course, you can put plus c. It doesn't matter. When you differentiate a constant, it will go away. So the general form will be, for this one, will be this. But the constant doesn't matter. So is it true? Yes. For Simplify the 4, subtract 1 from the power, x cubed. So the formula is x to n plus 1 over the same number. Prime will give us x to the nth power. Power rule. One more. I know I tortured you with this quite a lot. I would like, if we have f prime of x as -1 over x squared, can anyone give us the function or the family of functions whose derivative will be this?
It's negative x to the third over 3.
You can use this if you want to, but not the way you did it. Okay, let's think in the other, in a different direction. What function prime?
Over x plus c.
Exactly. So remember, I tortured you with this, and I said, please remember this, please remember this, please remember this. So when you differentiate 1 over x, you get -1 over x squared. So this is a very important result, if you want, because we're going to use it a lot. That's why I said, please remember, 1 over x prime is -1 over x squared. Why? Because now I need, when we find the antiderivative of this, going backwards, we have 1 over x. So please remember this. If you didn't do it already, please remember it moving forward. Okay, I think we are ready for examples now. This was the theory, and we're going to add more to it, but I think we should stop and look at some examples. Okay, so I'm opening on page, this is the last section of chapter 4, 4.9, page 362. I'm going to start with a simple example. Let's say page 361. Nothing is really simple in this book. Okay. 2x to the third minus 2/3 x squared plus 5x. And the question is asking us, find the most general antiderivative of this function. Okay. Since the notation is f of x, which notation will I use for the most general antiderivative?
Capital F.
Very good. And blah, 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 and I'll have plus a constant c. Good. Keep 2 in front. I'm adding 1 to the power and dividing by that number. Minus 2/3. I'm adding 1 to the power and I'm dividing by that result. And plus 5x squared, and I divide by that number. And this is it. This is the family of functions that has the given derivative. I will simplify a little bit. So I have 1/2, if you want to write it like this, you can, minus 2 over 9 x cubed plus 5 over 2 x squared plus a constant c. And that is the most general antiderivative of the given function. Yes, 17 caught my eye, and this is on 362. Please stop me if you have questions. Okay, so now f of x, the same question. And let's analyze that. Since we are given the f of x, we are asked to find the most general antiderivative. 2 over 5, who cares? What function prime is 1 over x?
Natural log.
ln.
Very good, with the absolute value of x. Excellent. Minus, I shouldn't put minus, I should put plus 3 to give you a hint. Which function prime is negative 1 over x squared?
1 over x.
That's it. Awesome. Plus a constant c. Done. What about 22? H of x equals secant squared x plus pi cosine x. They want us to find the most general antiderivative. Of course, if this is lower h, uppercase. Which function prime is secant squared?
Tangent.
Very good. Of course, plus pi. Which function prime is cosine? And do not ever forget plus c.
Sine x.
That's it. Awesome. Okay, moving on to the next step. Let me see how I'm here with time 16. Oh, I can stop and start anew.